Welcome everyone to the live stream CDK for Terraform workshop by and with the Mozilla Pocket team. Today we're going to learn how to use Mozilla Pocket's wonderful Terraform constructs and TypeScript to deploy services on AWS, and a lot less code and time than you might expect. But before we get too deep into it, we do need to cover our code of conduct, which is to be welcoming, inclusive, friendly, and patient at all times. Be considerate, be respectful, and be professional. And our wonderful moderator, Katie, is going to drop a link to the code of conduct in the chat, just in case you need it for reference. Okay, so moving on today, let's just go ahead and figure out who is on the stream with us today. And let's see here. Let's start with the folks from Mozilla who are going to be teaching us. So Kelvin, would you like to introduce yourself first?
Yeah. Hi, I'm Kelvin. I'm a senior software engineer with the Pocket team at Mozilla. I work on the backend team, and currently I work more to create services that empower our backend team and move Pocket's product that most people love forward. I'll pass it on to Mathijs.
Hey there, I'm Mathijs. I'm also a senior software engineer. I work on the data products team at Pocket. And thanks for having us.
And of course, we also have the product manager from the CDK for Terraform here with us as well. You'd like to introduce yourself?
Sure. Hi, my name is Sarah MacDonald, and as Cole mentioned, I'm the product manager for the CDK for Terraform here at HashiCorp, and really excited to be here for second workshop with the Pocket team, and I just can't wait to get into the demo.
Yeah, and my name is Cole Morrison, and I'm a developer advocate here at HashiCorp. Okay, so we've got this workshop today. Kelvin and Mathijs, why don't you give us a little bit of a heads up in terms of what exactly Pocket is for those who maybe aren't acquainted with it?
Kelvin, would you like to go?
I was gonna say you do it because you did it so well the last time. Would you like to go?
Sure. So Pocket started out as a save for later service where people can save their content, really anything that's on the web, but mainly articles. And they can read it anywhere, run a lot of devices, even offline. You can even listen to your articles. But we've started making a shift to making more of a recommendation service where we use all the great insight we get from people saving content to bring others who are with more of a discovery focus, the best of the web. And we do that with a combination of some really great curators, human curators, and recommendation algorithms.
Nice. Yeah. So for those of you with a aspirational backlog of bookmarks, this is something that can help you actually get through them and find new ones, right? Cool. So speaking more on to the workshop then, so now that we've got some familiarity with the product that this team is behind, why don't you tell us what we'll be doing today in a nutshell, Mathijs and Kelvin?
Yeah, so today we'll be deploying a service that consists of a web application and a database. And the great thing about it is that it'll actually be production ready when we're done.
Very nice, very nice. Did you have more on that? Sorry.
Sure, I can go a little bit further. So we'll be using Unleash as an example. Unleash is an open source service to do feature flags. Feature flags are flags you can use to turn functionality on or off without having to redeploy your applications to your clients. At Pocket, we use it to run A/B tests. So we can have a feature flag with multiple options that send people randomly to one of the options and thereby have a controlled experiment.
Nice. Do you have anything to add to that, Kelvin?
Well, Mathijs said that pretty clearly. That's what we're doing today with the deployment. We're excited to get to it and show folks how they can get something like this spun up production ready.
For sure. And so just so that the audience is on the same page, who is this for and what should they be comfortable with in terms of technology and skills?
Sure. So this is mainly intended for application developers who want to take more control over their infrastructure. I think CDKTF lent itself really well to application developers who are already familiar with the languages that you can write infrastructure in with CDKTF. And so we're using that to create patterns to build infrastructure in a reusable way.
Nice.
I'll add in addition to that, to this specific session is for folks that have some familiarity with Terraform, have some familiarity with some cloud infrastructure as well. Mathijs is going to go through some other prerequisites once we get going here.
Perfect. And that was actually what I was going to ask next, unless Sarah, you had anything you wanted to add in terms of what you would like to see, maybe directing the audience to focus on as we go through this, or maybe any input you might have.
Yeah, I guess I would just say to the audience that if you have some experience with Terraform and TypeScript, feel free to kind of follow along and use this as a workshop. If you're more just curious, I think you'll also just get a lot out of watching the demo and kind of picking up some of the concepts. So I would say it's kind of choose your own adventure. Will work for all sort of levels of experience.
Nice. So bridging into the workshop itself, before we hop in, what should our viewers have open or ready if they want to follow along? I know that y'all have a GitHub repo, but what else should they go ahead and have ready?
Can I start sharing my screen and go through a list of prerequisites? I think that would answer that question.
Yeah.
So on the right here, you see our repo, HashiCorp Pocket CDK. There's also a link to that in the description below. And at the top, you'll find a prerequisites section. So so obviously, like the first step is to have this code available on your laptop. We'll be working with Node, so that's required to be installed. Probably the biggest requirement to meet is to have an AWS account that has a Route 53 hosted zone. That means that you have a domain name available in your AWS account, and to have that AWS account set up on your laptop to use with the AWS CLI. And we provide some links on how to do that right here in our repo. I would say, just to echo Sarah, if you don't have this set up, just follow along, and you can always rewind and watch the video later and take your steps if you don't happen to have these already. If you do, and then finally, just a Terraform CLI, and we'll be using a Terraform cloud account in this workshop, but you can also save your Terraform state locally. And also to point out that this is, we'll be using our previous demo as a starting point. If you want to see exactly how we've created this template and get more information about all the code there, we recommend to watch our previous demo, and you'll find a link to that YouTube video in our repo as well.
Perfect. Well, we've got all of the upfront covered. And as mentioned, this, for those of you who are just gonna, take Sarah's advice and just sort of watching along casually to get a gist of it, but may want to come back later. This will be up on YouTube later today, so you'll be able to follow along at your own pace. But without further delay, let's go ahead and pass it over fully to you, Mathijs and Kelvin, for the workshop.
Cool. So just to reiterate what we're going to do. So we're going to spin up an application, uses Unleash. This is a ECS server that uses a database. And at the end, it'll be production ready, meaning that both the database and application will auto-scale. We'll have a dashboard to monitor your application. We'll have alarms that can trigger PagerDuty, and permissions are set up using the principle having the least privileges, which is a good security practice. So let's go down to our workshop steps. So I've already checked out our repo here. Just to a quick note about branches here. So I've checked out the main branch here, which is the place where we'll be starting, but we also have a branch that's called demo October 27th, which is the end result that we'll end up with later. You can just use this as an example in case you get stuck somewhere to see where your code might differ from a correct solution. We also have the code from our September 29th demo, which is slightly different from our main branch in that we've made it a little bit easier to run this code on your own AWS account instead of Pocket setup. So with that, let's get started with our workshop steps. So the first step is to create a VPC. And we provide a Terraform HCL template for that in the VPC directory. It's called main.tf here. And I'm just going to apply this. And while we're applying it, which takes a couple of minutes, we can talk a little bit more about the VPC. So I'm going to cd into the VPC directory. Oops. So we have our main.tf file here. I'm going to run Terraform apply. It's going to ask if I want to create these resources. I'm going to say yes. So while this is applying, Kelvin, can you talk a little bit more about what the function of a VPC is? Why do we have it?
Right. So what we're applying here is creating a VPC and using a module to create this VPC. Well, first of all, this module is going to create a VPC and then subnets to go with that VPC, along with some NAT gateways and internet gateways to go with this whole setup. But the interesting thing here that you notice is this is also being done with an HCL module, right? We could have done this in CDKTF, but we are using an HCL module because we kind of want to demonstrate that the shift to CDKTF is not an all or nothing shift, right? So something like a VPC, it's something that your ops team would be more familiar with creating, or that would be in their workflow. Your ops team can still continue using HCL, which is, the language that they might be familiar with, work with day to day, and don't have a problem working with, and then pass resources off that they create with these HCL modules, or even hand off some of these modules like we're doing here to the application team to actually use it and integrate it with their CDKTF, so that the application developers don't, have to know HCL, but they can still reap some of the benefits. So it's not an all or nothing thing. It's something that you can do alongside with your CDKTF. Now, the reason why we are also creating this VPC is particularly around security. We deploy all our services within a VPC. So, all services can communicate with other resources within that VPC, and not external services can hit that VPC. So for example, a database, for instance, for the service that we're about to create will be within that VPC, means it doesn't have access from the internet, but this application, the ECS service, would have access within that VPC to contact that database. So it's kind of like a security first approach to creating your services in cloud infrastructures.
And I'll also quickly mention that there's one parameter in this template you might want to change, which is the region. It's set to US West 2, which is Oregon, where I'm located. If you change that, also change the availability zones down here. And we provide a command in our repo to check which availability zones are present in your region. So you just run that if you want to change that. And we also provide all the steps to run. So just the Terraform apply. Let's go and check out what resources were created. So I'm going to type in VPC in the AWS console, open up the VPC here. I'm going to go to my VPCs. So this is the VPC that was just created. It corresponds with the name input here, test VPC. And later on, we'll be copying this VPC ID into our code to use it, as well as the IDs for the subnets. So these are the subnets that were created. I can just sort these on name here and make this a little bit bigger to actually see the names. So we see that there are 3 private subnets and 3 public subnets that were created, and we'll be copying these IDs as well. All right, so let's go to step 2, which is to organize our code a little bit. In the previous demo, we wrote all our code in main.ts, which is this file. But in practice, we often split out code over multiple files to have more oversight, to be able to find things easier. It's just good practice, I guess, not to have a huge code file with all your code in it. So that's what we'll be doing. So the first step here is that we're going to split out this config that's located at the top here into its own file. So what I'm going to do is I'll create a new file in source and call it config.ts. I'll choose to add it to GitHub here, and I'll copy paste, or actually I'll cut this config variable, including these names here, and paste it into this file. I'll change this to an export to make this config available when we import it later. And let me also copy over the VPC IDs that I mentioned earlier. So while I'm doing that, Kelvin, could you talk about like how we normally provide these identifiers to our application? We don't hard code these in our applications normally, right?
Kelvin just yeah, he just rejoined, so you may need to restate the question.
That's a demo effect.
Yeah, right.
So Kelvin, I was asking, like, how do you normally provide these values to our services? Because we normally don't hard code this, right?
I think he still may be
cool.
getting back oriented into it. Kelvin, you with us?
Yeah, my headset cut off, so I'm back.
Yeah. All right, so third time's a charm, right, Matthias?
Sorry about that.
This it's okay. This takes a little bit to copy this stuff over. I was asking like how we normally provide values like this to our services.
Oh, right. You wanted me to speak to that?
Sure.
So the way we build our constructs, some of them are very, specific to how we build things at Pocket using some of the practices that we use and some best practices as well. So for things like a VPC configuration with a VPC ID and subnets, if we don't provide one to the construct, we have it default to a sensible default that we use at Pocket. So we have a shared VPC and some subnets, private subnets and public subnets that we save in SSM parameters that we pull in if we don't provide any VPC config. This is all to make provisioning using our construct and provisioning services a lot easier for our team.
Cool. So the next value we'll want to change is your domain name. So like I said, one of the prerequisites is to have a domain set up in a hosted zone in Route 53. And you can choose what a subdomain that you want to host this service on. So my domain is my name.link, and I'll choose unleash as a subdomain. This can be whatever you want. And I'm going to leave the name here the same. This is the prefix that will be used for almost all our resources, to have them prefixed with the same name. You can also see that there are some tags that we'll share across resources, and that just makes cost analysis really easy and makes it a lot easier to find your services. You'll also note that we have a PagerDuty escalation policy. We'll explain later, like how to disable that if you don't have PagerDuty. If you do, then you'll want to change this to your escalation policy. And with that, I think we're done here, and we can import this into main.ts. So in here, we're going to import our config. So let's copy this import statement here. And then we need to make two small changes here. This was previously just referencing a constant that was in here, but it's now located in config.environment. Cool. And with that, we've moved our config to a separate file, and we've set up our VPC configuration. So that's on to step 3, which is to change the container image. In the previous demo, we used the image HTTPD, which is an Apache image, and we'll just we set up a simple server. All it did was reply with "it works" when it was spun up. So this time we'll be using Unleash. So we'll change the container image to this value, which is can use Unleash server version 4.1.4, which is I think currently the latest version. And next, we'll change the ports. Apache was launched on port 80, but Unleash needs to be launched on a different port. We'll be using 4242. And to do that, we'll actually add a variable in our config, so we don't have to repeat that port name everywhere. I'll call it Unleash port, and I'll set it to 4242. And then we can reference that really easily here. So there are 3 references we need to replace. It's the host port and a container port here, and then our exposed container ports. And last, we'll add an environment variable that tells Unleash on which port to start. So to do that, I'll copy over these environment variables, and I'll paste them inside the container config here. And this is simply setting up an environment variable that's Unleash will read when it starts, and it'll make sure to start on that port. All right, that completes this step.
So Matthias, I have a question for you.
Yeah.
So the pulling the main configuration out, so something we just did and completed, was an architecture pattern that you all follow at Pocket, right? Keeping those things separated so that everything's not into one file.
Yep.
Yeah,
that's right.
Cool. And then I was wondering, just for the viewers who maybe haven't gone through the previous one, I was wondering if maybe perhaps yourself or Kelvin, before we leave the main.ts file, could sort of walk through the higher level classes that you guys have set up here, just so we can get an idea of what each of them are doing for you.
Oh, that's a great idea. Yeah, let's do a recap of this file. Kelvin, could you walk us through this?
Yeah, I can walk us through this. So what we have here is, without all the meat in the middle, is the basis of how you use CDKTF with a class, and then a class that you new up with a construct, and then you synthesize. What is in here is us actually using a Pocket ALB application construct to provision production-ready infrastructure for a web service. What this does is it creates, if you joined our first demo, you would have realized that in less than 150 lines of code, we created this, and this provisioned ECS clusters, ECS services with their tasks, application load balancers, dashboards, alarms, and then a PagerDuty service that actually listens for the alerts and then notifies developers when some alarms breach the thresholds. That is where we kind of handed off last time. We have all of this code inside the repository in one of the branches that Matthias showed earlier. That would be a good place to get started. I'll hand it back to Matthias.
Yeah, maybe to reorient people a little bit on this file. So we have a constructor here that instantiate all the infrastructure on a high level, and then we put like specific resources into functions in this class. So for example, we have our LB application that's created by this function, and we just call it in the constructor here. And we list all our providers here as well. And this section, it references our Terraform cloud. So Kelvin, if people wanted to store the state locally, what would they do here?
You can just remove that remote backend construct, and then that would essentially not connect to Terraform Cloud to keep and version your remote state. It would just do that locally. So if you just want to do this locally and you don't have a Terraform Cloud account, you should just comment those lines out.
Cool. And then, yeah, like Cole mentioned, so a lot of this is just configuration, which is great. I think the more you can focus on your business logic, the better, the less boilerplate you have. So I love particularly this place where we could just focus on configuring our LB application, particularly flags like internal that say that this is going to be a public service. And if you wanted to make this private, it would be as simple as just flipping this Boolean. So I love how focused this is on exactly what we want to have in our service. Cole, does that about cover it? Any more points you want to mention about this file?
Oh, I think that was a good recall, just in the sense that you'll have a certain sets of infrastructure and services that are essential to any new services that you apply. You'll have abstracted those away into your Terraform constructs and made it so that you can configure them all in a very short amount of code for whatever it is that you need to provision. And that is what we have here.
Yeah, I think that's a great way to sum it up. Cool. Let's go to step 4 then. So in this step, we'll be creating our database. And I think this is really a really cool part of this demo. Just how easy it is to spin up this RDS. So first step is to create a new file in our source directory, and we'll call this database.ts. We'll copy over this template. So just to give a quick overview of what this is, it's somewhat similar to the codes that we have in main.ts in that it has this function that creates an RDS, and it uses Pocket's application RDS cluster. This is the construct that sets up an RDS according to Pocket's conventions. And then the body of this is the configuration that we'll be filling in to specify the specifics of this RDS. So to do that, let's copy over these configurations. So the database name, I'm going to call this Unleash. This is what your database is going to be called. Next up, our username. I'll just call this demo user. This can be whatever you want. It's the root user in the database that will be created for you. Next up is the engine. We'll choose Aurora PostgreSQL. This is what Unleash requires. It requires a PostgreSQL database. And lastly, we'll choose the engine mode as serverless. So before we talk a little bit more about what this will actually create, Kelvin, do you want to speak a little bit more to how this works, or what this will what resources will be instantiated?
Sure. Similar to how we have other constructs that provision a lot and make it easier for us to work with infrastructure, the RDS cluster construct that we have here, as the name implies, is going to create an RDS cluster. That's, the first obvious part. But what this also does for you is that it copies your credentials into a secret in Secrets Manager. That is important and, nice for us in two ways, or maybe just, I'll talk to this. One, we try to keep secrets outside of our Terraform state as much as possible. So, as you would with any version control system, you try to keep your secrets out of it. So what this does for us, it's instead of putting, keeping all that stuff in the states, we copy that to a secret manager instead, so that any implement application that needs this database would instead not, have the secrets as environment variables as it typically is, and just go to this other service, which is Secrets Manager, to pull those credentials instead. This helps us, kind of keep things, keep secrets littered out within our state. Mathijs, you want to explain what serverless is?
Yeah, sure. So, Aurora is a database technology by AWS. They have just written a very efficient way to run PostgreSQL databases. And Aurora supports a serverless mode where basically AWS manages the database cluster for you, enables you to scale really well. It performs really well, and just takes out all the DevOps of running a database. So I think we typically prefer using serverless database at Pocket because that's less work for us. That's always good. So just to round this out, a couple optional things you could change. So you see min capacity and max capacity here. These are capacity constraints. So it'll scale automatically up to a certain capacity. If you are expecting more traffic to this, you can increase this number. The minimum capacity is actually 2, so you can increase that if you like. We've set auto pause to false to prevent Aurora from scaling down completely if there's no traffic. In this demo setting, there won't be much traffic here, so just want to make sure that it's actually operational for the demo. And I really love like how quickly we set this up. Like I mentioned, the code is really focused on exactly what it's going to do, and it was just super easy to create this. Right. So that rounds out setting up the database. We can go to step 5 to connect this database with our application. So for that, we'll go back to main.ts. And the first step that we'll do is to import this to make it available here. So I'm going to add the import line to the top here. This exposes that function that I just mentioned here. Next step is to actually call that function. And like I mentioned, we do this in our constructor. We'll do it just before we create the application, because the application will need to use this RDS. So we'll say const RDS equals create unleash RDS, which is the function that we just imported. And next, we'll add a new argument to this create Pocket ALB application function, because we'll need to use the RDS inside this function. For that, I'm going to add RDS, and this is the class. This is our construct class, so that we've created with this function, create unleash RDS. I'll import it, and you can do it really quickly by hitting Alt-Enter and choosing Add Import Statement here. And you'll see that it's added it here at the top. Next up, we'll need to pass the RDS into this function. So we'll just add RDS inside that function call. And now we can use the RDS inside this function when we're creating our application. The first thing we want to change there is to provide permission to this secret. So we're going to copy over these permissions to the task execution role. Kelvin, do you want to remind us what the difference is between the execution role and the policy role, the role policy?
So in our construct for our IAM configurations, task execution role policy statements are the IAM permissions or policies that we provide to ECS when it's spinning up tasks. So for this instance, with the database credentials being in our in secrets manager, we need to give ECS the permission to actually grab those secrets when it's provisioning tasks and then set those as environment variables within the task. For task role policy statements, those are permissions that the application needs to when it's actually running to access resources within AWS. So this could be, putting something on S3 buckets, for example. So we would give permissions in a policy for this application to be able to, put files in S3, for example. So those are the two main differences. Task execution, default attachment, ARN, is just this nifty option that we added in here. So we could use manage policies from AWS, because they do have managed policies for quickly spinning up ECS tasks, which includes things like being able to write logs to CloudWatch, for example. So this was easy for us to make it available so we can provide managed policies as well to our systems.
Cool. And this is something I really love, how simple it is to pass this ARN into the secret. We can just reference this ARN directly from the RDS that we got, instead of having to formulate the entire ARN string ourselves. That'll mean that this a task has only permission to exactly this secret, and that means we're keeping our permissions as limited as possible. So let's go to the next step over here. So we're going to inject the values as environment variables in our application, so Unleash can read them. And to do that, we'll use some special syntax that Secret Manager provides, so AWS Secrets Manager. So the secret that's stored in Secrets Manager is actually a JSON object. It has the keys host, port, username, password, and DB name. And using this special colon syntax, we'll extract the value from that JSON and put the value eventually in the environment variable. As you also notice, as I copy this over, this is called secret envars as opposed to envars. And the key difference there is that the value is defined as a reference to the to a secret as opposed to a literal value. So we just provide the ARN here, which is not secret by itself. And then AWS will pull in the actual secret at the last moment when it spins up these ECS tasks. So I really love how we're passing around secret values here and keeping that secure. Anything you want to add to this, Kelvin?
Oh, you hit that nail on the head. This is how, as we were talking before, we try to keep secrets out of our states as much as possible.
Yeah.
So I do have a question for you before you move on to step 6, Mathijs.
Go for it.
Yeah. So Rosemary asks, do you implement variable validation within your code, or do you use Terraform's input validation? So for example, for database credentials conforming to AWS policies.
Can you repeat that question again?
Yeah. Do you implement variable validation within your code, or do you use Terraform's input validation? So for stuff like database credentials and needing them to conform to AWS's policies, for example.
I would say we use validation because we use AWS. We use validation that conforms to what AWS expects. So in most of our constructs, for example, we do some validation. One example would be for something like an A or B prefix. We do validation within the constructs themselves. So if you pass anything that is not acceptable longer than 6 characters currently, we would reject that. So, you would get an error before you actually synthesize your whole code, for example.
Gotcha. So in essence, you implement your own within your constructs.
Yes.
You following what it is that you need to from AWS.
Mm-hmm.
Okay, cool. Thank you.
Sweet. Let's go to the next step, which is actually deploying this. So for that, we'll go back to our terminal. I'll go back to the project root here. Let's install all the dependencies using npm. I'll actually do npm CI, which will not update the log file and just install from it. And that should be pretty quick because I've already installed these previously. Cool. So next up is to run npm run build. And while this is going, Kelvin, can you explain a little bit more about what this does?
So npm run build essentially is running TSC command and then also running npm synth. Since we write all this code in TypeScript, we need to actually compile it down to regular JavaScript. So the synth command can actually synthesize all that code into Terraform friendly JSON. And that is what the build command essentially is doing. Here you'd see that we are setting the node environment to development because we're building all our resources and tagging it with dev, but at the core of this, it's just compiling the code and then running synth to transform this into Terraform friendly JSON.
Cool. And the output of this is located in CDKTF.out and then stacks and then your stack name. So I'm going to cd into that. And you'll see that this contains CDKTF.tf.json. This is the JSON that was generated. So first step that I'll do is run Terraform init. Oh, actually, before we do that, we should make sure that we're using the right Terraform version. So I'm using 1.0.9. We use tfenv to manage our Terraform versions. If you want to make sure you're using the right version, you can just run tfenv use, and it'll pick up the version that we've specified in the Terraform version file. That should be in our project roots. Do we have a version file here?
We do not have one in here, but we are on Terraform 109, and we will update this repository after this.
All right. So first step is to run Terraform init. Cool. Next step is to run Terraform apply. Should I make this a little bit bigger? I can make this.
Yeah, that would be great.
It says no matching VPC found. So I'm going to double check that I copied over my VPC values correctly.
This will probably have to do with the region that the application is being deployed in.
Oh, you're right. So I forgot to mention that there's actually a configuration here in main.ts. At the top here, you can specify region, and you have to make sure that this is the same region as you use in your VPC main.tf file. So I used region US West 2 here, and I forgot to update this. So I'll change it to US West 2 to match the VPC. So because I made a change in my TypeScript code, I have to regenerate the CDKTF file. And to do that, I'll do npm run builds. Should I do this in the project root? I think I can do it here as well, but we typically always run this in the project root. So just to be sure.
And all of these steps that are happening here, just to add, are typically run in our CI. We don't build this and manually go type out this in individual terminals. Most of these steps are run in CI. So on push, it would run this and then run a Terraform plan to actually check that we have the right resources going to be created, deleted, what have you, and then we would run apply when you merge to main.
I have another question for you. If you have a moment.
Go for it.
Nice. So can you parameterize the region across all the configurations? So like you setting as a constant, for example?
I think that's a great question. So this is between HCL and CDKTF. I'm sure you could. So like Kelvin mentioned, we normally store these configurations in a parameter store, so we don't actually like hard code these values. And I'm sure you could do the same thing with the region and pull that in from parameter store as well. What are your thoughts, Kelvin?
Additionally, for region, if it's being used to, say, configure the provider for AWS, that accepts a couple of options. You can, one, do it in code like we're doing now, or you can actually set that as an environment variable. So if you're working between HCL and CDKTF and you're configuring something like an AWS provider, you can set the AWS region as an environment variable in your CI environment or wherever you're running this. And then both of those systems, both of those HCL or CDKTF will pick that up. Right here, we are setting it in the code. So it kind of requires us to change it in the code, or we can put it in a config. But if we do put it in a config, then anything else that we create, whether it's a database, a caching system, anything else that we create would have access to that configuration, since it's all kind of TypeScript code, which is one of the nice things about using a language, that you're already familiar with, and a language that conforms to, most programming languages. For what you would do in HCL, you can also set your vars, which is kind of what HCL takes in as like inputs and parameters. You can set that as well if you wanted to, kind of do that in CI, and everything else that you create in HCL would also use that. But it really depends on what you're doing. If it's region in very specific places that you can't configure through an environment variable of some kind, then I think for HCL and TypeScript, you'd have to keep those slightly separate and keep them in sync. But, if you're building it with CI, there's always ways to sync those up where you use, one source of truth for your region, and then pull that in and then configure it however the specific way you implement it, whether HCL or in TypeScript uses.
And in practice, we run this like Terraform to create our VPC only once, and we deploy it separately from where we deploy services. So these typically wouldn't be applied in the same environments, despite that I'm not doing that in the same terminal. So speaking of applying, so this is ready to be applied. It's saying it's going to create 48 resources. I'm going to say yes here. And Kelvin, you already mentioned that we normally don't write code like this in our terminals. Can you talk a little bit more about how we do CI/CD at Pocket?
Yes, sure. So the way we do CI/CD at Pocket, as I kind of mentioned a little bit earlier, is we do it based on our VCS, which is GitHub. So when we do pushes to, you create a pull request for a change that you want to make, that kicks off a build that basically runs the npm run build, generates a Terraform CDK JSON, the Terraform friendly JSON. It runs an apply on that, a plan on that to just, validate that, first of all, it's valid Terraform. And then secondly, it also allows you to inspect the resources that would be modified, created, deleted, or updated. Once all of your code is reviewed and everything looks good, the next step is to merge that to main. Once that is merged to main, another CI job kind of picks that up, runs the same steps, but instead of a plan, it runs an apply in a CI environment. The way we've kind of gotten around building this CI environment is to, use code build, which is within AWS, but that's very specific to the cloud infrastructure that we're using. But the high level there is that the CI would pick that up and then run an apply instead when you merge to main. Some of the ways that we kind of, give confidence, to ourselves and to our systems that, this is not going to, break production or, cause any issues with our environment is to, for example, the Pocket application ALB that we are using, the construct that we are using right now, typically internally, we would configure the code deployment application as part of the whole deployment. So when we do push it out, we run a code pipeline that actually runs the Terraform apply and then takes the new task definitions from ECS and then tries to perform a blue-green deployment. So that would, first of all, try to deploy it, run health checks on the tasks, on the containers themselves, first of all, and then run health checks on the ALB. So if at any point any of those fails, it's basically going to roll back, and it doesn't actually send traffic to the new system until it passes those health checks. So we kind of give ourselves that kind of confidence, with the tools that we use and what we've built into our construct, that we are deploying an application that is actually ready for production traffic, and it's not, going to bring down Pocket or any part of Pocket.
We've come a long way from deploying things by opening SSH and deploying it manually. We've gone through many stages at Pocket of how to deploy services.
Yeah, we used to do some cloud formation in the beginning. That kind of got painful very quickly. We switched to HCL, but the way we were kind of using CI, we also could not, create. If you're familiar with, Amazon and IAM permissions, we cannot, we do not want to trust the third party with the permissions to create IAM permissions, willy-nilly in our accounts. So, we've gone through some iterations of how we do that and have gotten to the point where, we can put all of that stuff in Terraform and then run that and have it create all the permissions, lock services down to what we need.
Interesting. While this is still going, in terms of your modern continuous integration deployment pipeline, do y'all build that as well, like with the same process, with the same tools?
So with the way we work now, when we start a new project and create, say, a GitHub repository for it, we also have an internal repository where with about 5 to 6 lines of code addition, you basically tell it what the repository is, and then it goes ahead and creates all the foundation for CI. So we use Circle CI in Pocket. It goes ahead and sets up the project for Circle CI. It creates a code build. It basically sets up that whole infrastructure, creates the IAM permissions that Circle CI user would actually need to, say, push images to ECR, for example. It sets all of that stuff up, and all of this is also built with CDKTF. So there's a lot that we've gotten out of, switching some of our processes to CDKTF, where we are more familiar with the language. So it's easy for us to integrate it into more of our processes as well.
Wow. So you're building your CI pipeline with CDKTF so that it can then build out CDKTF stuff.
Pretty much. It's an inception of CDKTF.
Nice.
Well, with that, our deployment was successful. So let's see if we can reach a service. So the domain name is unleash.myname.link. Oh, Kelvin, do you think it's probably still deploying, right?
Probably still deploying.
Yeah, it takes a while. So while that's going on, let's actually look at the resources so we can see what's going on here. So I'll go to ECS here. So you can see there's one cluster here. So ECS is an AWS resource to run your Docker containers. And you can actually click into here and see that we've got some task provisioning. So there's one running, one provisioning. We can look at our RDS. So we spun up a Postgres database that's fully managed by Aurora. That is located right here under databases. So you can see this is up and running. And maybe we can look at our ALB to see if it's gotten like healthy checks back. So all of this, there are actually like quite a few resources that have been created by, what is it, like just under 200 lines of code, I think. It makes it so much more easier to spin up new services. So it doesn't have any data yet. It just takes, I think, a minute for these new tasks to register. Kelvin, how many resources do you think were created now? We can actually, I guess like it's 48. So
yeah, 48. It includes a lot of things that we don't mention at a high level. It includes things like security groups that are set up just right to allow traffic to application. It includes dashboards and alarms that have been created. Those alarms have actions. It includes SNS topics that have actually been created to send those alarms to, that is integrated with PagerDuty as well. It creates a whole slew of things, but at a high level of that, it's creating an ECS cluster with a service, with tasks that are running your application image, with a load balancer in front of it to handle the traffic that comes in, with auto scaling to scale up your services for traffic demands. We just added a database that auto scales by itself to go with that application that auto scales as well. So you have kind of like the whole package in one by just using this one construct, which also kind of made possible for our team using CDKTF, where we can deploy an application. We have all we need, and all we have to really set up is our alarm thresholds and SLOs and things like that.
I love that I don't have to think about all those details anymore, and I can focus on the application. So here it is. So this is Unleash. Comes with a standard username and password that you can find in the Unleash docs. I'll sign in here. This is the interface. So as I mentioned, this is a tool to create feature flags. So I can add my first toggle here, give it a description, and hit create. And so this is the toggle. Go back to the home page here. So it's create the toggle and comes with an API for clients to hit this, and with a whole bunch of features to do more advanced things like just enable or disable a new feature. So that's our last step. Like Kelvin mentioned just now, all of this scales automatically. We set it up securely. We have monitoring alarms going to PagerDuty. So this really is like ready for production traffic.
Nice. So looking at everything you just did there, I could take this and more or less swap out the image, redo some of the ports, and using your else constructs, be up and running with this type of infrastructure pretty quick then, yeah?
Yeah, exactly.
Yeah, nice. I have some questions for you around the constructs, and I'm sure Sarah probably has some questions too. One of the first ones is, at what point do you determine to turn something into a new construct? Like, what is okay, that's it. I'm not rewriting this again. This needs to become something that we can just pull in.
Kelvin, do you want me to take a stab or?
Yeah, take a stab.
I think it's when multiple of our services start using the same patterns. The great thing about CDKTF is that you can use these constructs and extend them in the service itself if there's something unique about that service. And if you know TypeScript, it's just very easy to extend that. You can use all the constructs that CDKTF provides for you. So it really gives you a lot of power, which is what makes this approach different from some of the other ways that you could spin up a server really easily. Like Amazon offers ways to make it very easy to spin up databases and application servers, but you then lose the control to add resources to that. So this really gives like a full control over your infrastructure, as well as making it really easy to get started. So yeah, when we start seeing like the same pattern pop up in multiple services, we can abstract that into a construct in our shared library.
Nice. And so my second question for you is, when you're creating these constructs, what does it look like when you're making them in the attempt to make sure that they work with all of your other ones as well? Because I'm sure that's probably a jigsaw puzzle to some extent, right?
Kelvin, I think testing is really critical there, right? Do you want to talk a little bit more about how we do that?
That's kind of one of the things that we did mention as we're going through the code. But because we're writing this in, a typical language, you can write this in, any other language, but we're doing this in TypeScript. You can write tests just like you would for your application code for the infrastructure code as well. And what we do to make sure that, our constructs don't have conflicts or they work well together and generate, viable CDKTF JSONs is to run tests. And we typically use snapshot testing to run tests where we integrate the application, the constructs with each other, and then make sure that they actually like spitting out the right resources, the right JSON to actually build the resources in the way we expect them to. So with CDKTF, you can actually write tests like that. That was one of our, our struggles with HCL. I know this might not be true for every team, but, for us, we always had to like push it out to like a dev environment, for example, before, to just validate that what we are doing will work well together. But with CDKTF, we can actually get some assurances before we actually go run a test in our dev environment. So it saves us some time during development to run the test locally, kind of have some assurance that this is going to do the right thing, and then finally test it, as opposed to, push into production, push into a dev environment every time we are just kind of developing like a new module, for example.
Yeah, and I really love being able to use like all the great libraries and techniques that people have come up with to write automated tests and apply those to our infrastructure. I think that's really powerful.
Yeah. And then the nice thing is like, you're using a language that has like a lot of support, a lot of community support. You can pull in libraries to, like slugify strings or like to pretty much do anything. If you know the Node ecosystem, like NPM has pretty much a library for anything. So when it comes to, like string manipulation, data manipulation within your constructs to, provide certain things for certain resources, is really easy to just pull in like things that exist within the community.
Cool. So since we've kind of come to the end, before you Terraform destroy all the things, and before we get into any more questions, someone was asking if we could walk through the Terraform code, not the Terraform code, the TypeScript code that we've put together. And I think that would also be a good time to do sort of a high level recap, if y'all wouldn't mind, of everything we just saw and just sort of walk through the code as you go.
Yeah, how about I open up the code in GitHub here. This is a pull request here. You can see with all the changes we made, and we can just focus on all the steps we did. So
Nice.
starting out, we separate out our config into a separate file, and we set up the VPC variable values there. We created a new file for our database, and we configured that to use Postgres and Aurora serverless. We set up the database name here. Next up, going to main.ts, we moved the config here, and we imported the database function to create the RDS. Change the region here. This has to match the VPC. So this is the constructor. We added a call here to create the RDS, and we passed this RDS into the create pocket LB application function. Inside that function, it's being used. So we also changed the image name to use Unleash. So this is the Docker image that Unleash provides to host its Unleash server. We passed in the ports here as an environment variable, as well as in the host port and the container ports. We passed in secret environment variables, which allows the application to use the database. So it passes the credentials to it. We use the special secrets manager syntax here to pass the values from the JSON object that's stored in secrets manager as environment variables. We gave the task permission to use this secret when it's starting up the cluster. And apart from some minor changes, that's it. So that brings us to, see how many code changes. Less than 100 lines added and 33 removed. So I think that's pretty awesome to, that it's this easy to change your service to host something completely different than the Apache server that we started with.
Absolutely. That was a good way to walk through the code changes. It's amazing how something simple like a pull request can give you so much insight. I like leveraging that. That was good. Cool. Well, so that brings us here closer to the post demo section. Just going through, were there any other comments or thoughts or questions you might have, Sarah?
No, I mean, sorry, my dog chose this moment to start barking. I think what's really nice about this is not only seeing how quickly you were able to work through this code, but also just how legible the final product is. Like, it's really nice, I think, to see, just from my perspective as someone, right, who didn't write the code. I feel like someone else on your team could come back to this later, easily see what you did. It's just set up in a really easy to read way. And I think it's nice the way you kind of got your system set up that way as well. So yeah, just really fun to kind of watch it all come together.
Nice. And as you watched our incredible instructors go through their demo, were there any things that Sarah, that made you think, oh, cool, that's a little wrinkle in the workflow, or something that maybe is that the CDK team has coming out soon? to any future releases or anything?
Well, I think, yeah, not necessarily like features per se, but it's definitely really helpful to see this workflow live. I think we are definitely focusing. Our next release in 0.8 is much more of like just like a usability focus. So just looking at existing features we have and kind of how can we make the ergonomics a little bit better. So definitely, yeah, just great to kind of see this going through live. It was also really interesting. I didn't realize that your CI workflow itself is kind of like built using CDKTF. So I'm kind of curious to maybe offline get some more details on that. That's a really interesting use case as well. So yeah.
Nice. Well, that was a lot of great stuff. And I was going to ask you more about the continuous integration deployment process, but we already went in depth in that in the middle there. And then as Sarah just brought up, we can talk more about it online, but it is very interesting that you're using the tool to then use it again to use the tool. Yeah. So any closing comments for the demo portion of this, Mathijs or Kelvin? Or maybe any questions you all have in general for each other, maybe.
I think we're still really happy with our choice to use CDKTF. So thanks so much for providing that and for making it open source.
I just echo what Mathijs just said. We're really happy with the choice. We are always like, looking for new inventive ways to use it to make our flows a little easier. So we're excited that you made it open source. Our Terraform modules repository is how we are also trying to contribute with, the free stuff that we got, trying to put some free stuff out there. It's open for external contributions as well. I've seen, someone from Terraform actually PR to it, which has been really nice. So, if you get in there, you're using it, there's something you find that, could be better or something you want to add, go ahead and submit a PR. The team will review it and we'll get that in there.
Nice. Well, thank you so much, Mathijs and Kelvin, and really Mozilla Pocket in general for both putting this workshop together and also for using the tool. Y'all are advanced users, and that helps push us all forward because you'll discover things in your workflows that we wouldn't otherwise see. If you're watching this live and you're like, oh, I want to go through it at my own pace, don't worry. We're going to post this back up onto YouTube, the recorded version here later today. So you'll be able to take it at your own pace, whether that's faster or slower. Now, for those of you that are just getting started with the CDK for Terraform, don't forget that we have our Learn guides at learn.hashicorp.com. We've got a ton of foundational resources there that'll get you up to speed so you can start building infrastructure with the CDK for Terraform in your programming language of choice that we have supported. And also be sure to stop by the GitHub repo for the CDK for Terraform. We do watch it. So if you have any ideas, feedback, or issues, be sure to leave them there. We're grateful for anything that you can tell us. Now, for the intermediates out there where you were in this workshop and you're like, okay, this has got my wheel spinning. Where can I get more of this? As they mentioned, Mozilla Pocket, their team has a ton of great repos on their GitHub account that you can go check out that have a lot of best practices and architecture patterns that you can learn from. And lastly, give Pocket a try, right? Bookmarks all over the place. Come on, you find something, you put it in, it's gone forever. Their product will make it so that you can organize them, full text search them, highlight it, and actually get that information in your brain. And you'll be supporting a great company in Mozilla and a great team in Pocket. So with that, any last words, Kelvin, Mathijs, or Sarah?
Think you said it really well, Cole. Thank you so much for having us.
Yeah, thank you.
All right. Thank you, everyone, for who came and watched, and I hope you enjoyed it. Until next time.